Hello student. So that day we have discussed up to your exercise 1.1. So today we are going to discuss the exercise 1.2. So first of all of you take out your NCERT book number system, your page number 7. All of you take out the NCERT book number system, page number 7. All of you take out your NCERT book of page number 7. So today we are going to discuss numbers system part 2. Okay, so now see, first of all, that day we have discussed irrational number. Yes or no? That day we have discussed rational number. So today we are going to discuss the irrational number. So first write down what is irrational number. All of you first write down what is irrational number. So write down irrational number. So write down the definition of irrational number. Write down a number is called irrational number if it cannot be written in the form of p by q, where p and q are integers and q does not equal to 0. So all of you write down the definition of irrational number. All of you write down the definition of irrational number. So write down a number is called irrational number if it cannot be written in the form of p by q, where p and q are integers and q does not equal to 0. Now see, that day we have discussed, suppose 2 by 3, 5 by 3, 3 by 5. Yes or no? These are the rational number because it can be expressed in the form of your, yes or no, it can be expressed in the form of your p by q. Yes, it can be expressed in the form of p by q, and where q does not equal to 0. Yes or no? So but suppose one number is but you cannot express like this 1 by 0. It is a irrational number. Why? Because here you cannot write down 0 in the denominator, because the criteria is q does not equal to 0. If you write 0 in the denominator, then it will be not defined or infinity. Yes or no? That's why you can't write 0 in the denominator. So just remember that what is the irrational number? A number is called irrational number if it cannot be written in the form of p by q, where p and q are integers and q does not equal to 0. So all of you pause the video and write down the definition of irrational number. Okay. Now see. So what is your irrational number? Now see. Suppose your root over 4. We know that 4 is a perfect square. So root over 4 we can write 2 square. That means 2. That means that's why root over 4 is a rational number, because we can express root over 4 as 2, and 2 is a rational number. But if you express root over 3, is it rational or irrational? Tell me, it is rational or irrational? Root over 3. It is irrational number. Why? Because if you find out the square root of 3, approximate value is your 1.73. But it is your approximate value. Okay. If you are going to find the square root of root over 3, then it will be 1.7, suppose 3, then 6, then 5, then 5. It will be go to infinity. So we can't express. Why? Because we can't express 1.7. Now see, suppose one number is given, suppose 2.5. You can write down 2.5 as P by Q as 25 by 10. Yes or no? Yes or no? 2.5 is a rational number. Why? Because you can express 2.5 as 25 by 10. That's why 2.5 is a rational number. But if you are given suppose 2.56, then 7, then 1, suppose 3 to infinity, then you can't express 2.56713 up to infinity as a rational number. Because why? We can't express this term in terms of P by Q. Because why? We don't know the value. What is when it will end, when it will terminate. We don't know the value when it will terminate. So that's why we can't express it is in the form of P by Q, and that's why it is a irrational number. In the same way, your root over 3 or root over 5 or suppose root over 3. Root over 3 is 1.7, then your 3, 6, 5, 1, something like that, up to infinity. So you can't express root over 3, suppose the actual value is 1, so you can't express, because we don't know where it will terminate or where it will end, we don't know. That's why we can't express this one. But if suppose one fixed number is given, suppose 1.567, after decimal 5 digits are there, so we can write 5, you can express 1.567 as 1567 by divided by 1000. Yes or no? It's a fixed number, then terminating digit. Yes or no? Terminate, it will terminate, it will end at some point, because at the third point it ends at the third point. But here we can't say where it will end. That's why we can't express root over 3 as a in terms of P by Q, because we don't know after decimal how many digits are there, we don't know, because it is up to infinity. That's why we can't write on the denominator. But here we know that after decimal only 3 digits are there. Only 3 digits are there. Yes or no? After decimal only 3 digits are there. So we can express by dividing by 1000. So it is a rational number, but it is a irrational number. So what can we conclude from this? That when a square root is a, suppose you are given a square root of 2, because 2 is not a perfect square, root over 3, then your root over 5, then your root over 6, then your root over 8, then your root over 10. These are not perfect square. So when you write down the square root of any non-perfect square, then it will be a irrational number. It will be an irrational number, because when you calculate square root of 2, it will be a what? You will get a approximate value. You will not get the actual value, because suppose root over 2, its value is 1.43456, something like this, up to infinity. So you can't say correctly or accurately when it will end. But for our convenience, we take it as a up to 2 decimals. So it is 1.44, or it will be 1.435. So we'll take it as a 2 decimal. Yes, no, 1.44. For our convenience only, we can take up to 2 decimal. After decimal, up to 2 digits. Yes or no? That's why. So root over 3 also, it is not a perfect square. Root over 5 is also not a perfect square. Okay, tell me one thing. What do you mean by perfect square? See, perfect square means 1 is a perfect square, because 1 you can write as 1 square. 4 is a perfect square, because 4 we can write 2 square. 9 is a perfect square, because 9 we can write 3 square. Then your 16 is a perfect square, because 16 you can have 4 square. So, but 2 is not a perfect square, because we can't write 2 as a square of any number. Yes or no? Square root of any number. We can't write 3 as a square root of any number. That's why 2, 3 are not perfect square. And when your square root of non-perfect square is given, then it will be an irrational number. Because why? It will not terminate at a fixed point or a fixed decimal, but fixed digit, after decimal fixed digit. But when you write down the square root of 4, it will be 2. When you write down the square root of 9, it will be 3. Yes or no? When you write down the square root of 16, it will be 4. So it will end. That means square root of 16, we know 4, and 4 is a rational number, a whole number. Yes or no? That's why if you are asked to write down any irrational number, just you can write the square root of any non-perfect square, root 3, then suppose root 5, then suppose root 18. These are the non-perfect square. Okay, and again there is one thing you are going to we are going to discuss in our next topic, That means your terminating, non-terminating, then recurring, non-recurring, yes or no? So this will we'll discuss in the next topic. Just I'm giving just some hint. Suppose this one, your 0 point. Suppose this one your example is given in your textbook, page number 86. Suppose 0.101, then 1, then again 0, 1, 1, 1, 1, 0, 1. Now see, up to infinity. So it is a your what is it is your one irrational number because it is non-terminating. Yes or no? Non-terminating digit. So this so it is irrational number. But one thing again, in the next that means in the next topic or next chapter, we are going to discuss. Suppose something like this: 0.11, then again 11, then again 11, then again 11, then again 11, something like this. Is it rational or irrational? It is rational or irrational. Though it is non-terminating, but it is rational. Why? Because it is a repeating number. Now see, the repeat is 1, 1, 1, 1, 1. The same number is repeating. Yes or no? Same number is repeating. So non-terminating repeating number is your rational number. Suppose 0.12, then again 1, 2. Suppose 0.12, then again 1, 2, again 1, 2, again 1, 2, again 1, 2, up to infinity. Is it rational or irrational? Is it rational or irrational? It is non-terminating. That means we don't know where it will end. But it is a rational. Why? Because it comes in a pair, same pair, 1, 2, 1, 2, repeating digit. Yes or no? Recurring. That's why it is a non-terminating repeating digit. Repeating digit. We are going to discuss details in our next topic. Non-terminating repeating digit. That's why it is a rational number. That's why it is a rational number. Okay. That's why it is a rational number. But it is suppose 1, 5, 6, 8, 9, 1, 0, 2, 3, something like this. It is also non-terminating, but it is a non-repeating. It is a non-repeating. Yes or no? It is a non-terminating, non-repeating. That's why it is your irrational number. Okay. So what we can conclude that when a number is a non-terminating repeating digit, that means now see 1, 2, 1, it is repeating. Same pair is repeating 1, 2, 1, 2, 1. 2. Though it is non-terminating, but it is same pair. That's why it is a rational number. But see the next example: 0.56891023 ... That means up to infinity. It is also a non-terminating number, but here the digits are non-repeating digits. Yes or no? Here the repeat are not repeating. Yes or no? 56891023. That's why it is a non-terminating, non-repeating number, and that's why it is a irrational number. But it is a not digit, it is number. Yes or no? Non-terminating repeating number. Non-terminating, that means it is not. It will not. We don't know where it will end. So it is non-terminating, but it is a repeating number. Repeating is yes or no? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. It is comes in a pair. 1, 2, 1, 2, 1, 2. That's why it is a non-terminating repeating number. And non-terminating repeating number. Remember, non-terminating. That means terminate means end. Okay, non-terminating and what? Non-terminating and repeating number or repeating digit. It is your rational. Okay, rational number. Such number is a rational number. But when it is a non-terminating, non-repeating, then it is a irrational number. Okay, it is a irrational number. Okay, so this is different. In details we are going to discuss. So one example of your suppose you are asked to give some example of irrational number. So the first things that comes to your mind is the square root of your non-perfect square. Yes or no? Suppose root 2, suppose root 2, then root 3, then your root 5, then your root 6. Again, you can write non-terminating, non-repeating. Suppose 1.135789. You can write anything. This is the example of irrational number. It is a non-terminating but non-repeating. After decimal, are the digits are repeating? Yes or no? The digits are non-repeating. That's why it is a irrational number. Clear? So these are the irrational number. Now, come to the next topic. Our next topic is a real number. Very important, real number. Okay. So what do you mean by real number? What do you mean by real number? Now see, suppose we know the number line. That day we have discussed the number line. Yes or no? That day we have discussed the number line. Number line, suppose this is a number line. Suppose this is a number line. Here 0. On the right hand side, 1, 2, sorry, plus 3, then plus 4. On the left hand side is minus 1, then your minus 2, then your minus 3, then your minus 4. Yes or no? It's a number line. So we can express, that means 1 is also a real number, minus 1 is also a real number, 2 is also a real number, minus 2 is also a real number, 3 is also a real number, minus 3 is also a real number, 4 is also a real number, minus 4 is also a real number. Yes or no? Minus 4 is also a real number. 1 minute. Okay, so minus 4 is also a real number, but so real number we can express in our number line. Yes or no? But suppose root over minus 1 or suppose root over minus 4, these are not real number. In your higher class you are going to study, it means your 11 or 12, root over minus 1 we can add 1 into minus 1 or minus 1 square, or 1 minus 1 square, minus 1 we cannot minus 1 square, minus 1 we can write I square. I is an imaginary number, I square. That means the value of I square is your minus 1. Okay, you are going to get this type of theory in the class 12 or 11. So when you square root, it will be I into root over 1. That means it will be I1. That means I. So these are the imaginary numbers. Suppose root over 4. Root over 4 you can write 4 into minus 1, that means 4 into I square. So you can write this, if you take 4 to the outside it will be 2I. If you take out I square, the square root will be I. Yes or no? This is 2I. So root over minus 4 is your 2I. I denotes imaginary numbers. So these are the imaginary numbers. Except this one, all numbers are your real numbers. So this is your extra knowledge. You can you are going to get this knowledge in your class 11 or 12. You are going to apply this imaginary number, real number, yes or no, in details, especially the imaginary numbers. So real number, the main thing is what I'm going to discuss is the real number. So real number. So real number, that means the number which we can plot in the number line. The number which we can plot in the number line are called the real number. This is the basic definition of the real number. So what is the basic definition of a real number? The numbers that we can plot in the number line is called the real number. So all of you write down the definition. I am dictating it. The numbers, the numbers which we can plot in the number line are called real number. Clear? The numbers which we can plot in a number line are called real number. So real number includes all the integers, minus 4, minus 2, whether it is negative or positive, 1, 2, 3, all the rational numbers, 5 by 4, 6 by 4, 1, root over 4, All the irrational number also root over 3, root over 2, root over 5, 0.1111, 0.135667. All these are the rational numbers. That means the numbers that we can plot in a number line are called the real number. Yes. So what is the definition of real number? The number which we can plot in a number line are called the real numbers. The example of real numbers will be all the integers: -3, -4, 0, 1, 2, 3. Then all the rational number 5/4, all the whole number, fraction, natural number, all the numbers are real numbers. Then 3/4, all the irrational numbers, suppose root over 3, root over 5, root over 6, suppose 1.13213567 this one. Again one thing, 1.135. It is a rational or irrational? It is a rational because it will end after 3 digits, so it is a rational. So all the rational number, all the irrational number, all the integers, all the fraction, all the natural number, whole number, all these things are real numbers. So real number is actually your combination of all the numbers except the imaginary numbers. Clear? So this is the real numbers. So you can also write down like this, that the collection of real numbers, and it is denoted by what? Real numbers, it is denoted by capital R. Okay, real number is denoted by your capital R. So the collection of all the rational number and irrational number together, or you can write the collection of all the rational number, irrational number, integer, natural number, whole number are called real number. You can write any definition. The number which we can plot in the number line are called rational number. This is one definition. You can write another definition. The collection of all the rational number, that means this one, rational number, irrational number, then your integers, your natural numbers, whole numbers are called the real numbers. Clear? So this is the definition of real numbers. Okay, and if you are asked to give some examples of real number, you can write down like this: any number except your imaginary numbers. Okay, and in a higher class you are going to study the imaginary numbers. Clear? Okay. Now see, next thing is the next thing which come to our, okay, now we are going to plot the irrational number on the number line. Okay, so in the exam you are asked to plot irrational number on the number line. Suppose now see your page number 7, all of you. See the page number 7, all of you. Locate root 2 on the number line. That means you have to locate root 2 on the number line. So how can you locate root 2 on the number line? Suppose this is a number line. See the example 3. All of you see the example 3. You have to locate root 2 on the number line. Okay, so root 2 on the number line. So first you have to draw the number line. Well, let me draw here. Okay, suppose this is your 0, this is your 1, this is your 2, this is your -1, this is your -2. Now see, whenever you are asked to plot any irrational number on the number line, the first thing that come to your mind, and should come to your mind, that root 2 we can write, how we can write root 2 as in the Pythagoras theorem. You know so in the letter you are going to study the Pythagoras theorem. I think in the class 8 you have found the Pythagoras theorem. Suppose this is a triangle right angle at B. So this is the perpendicular, this is the base, this is the perpendicular, this is the base, and this is the hypotenuse. So Pythagoras theorem says that hypotenuse square equal to perpendicular square plus base square. This is the Pythagoras theorem, and this can be applied only on the right angle triangle. Right? What is the right angle triangle? A triangle whose one angle is 90 degrees is called a right angle triangle. Now see here, root 2 you have to write down as, you can write as 1 square plus 1 square. Yes, root 2 we can write 1 square as 1 square, because 1 square is 1, 1 square is 1, so it will be root 2. So root 2 we can write as 1 square and 1 square. So you have to first, that the thing that should come to your mind, that how can we write down root 2? Root 2 you can write 1 root over 1 plus root over 1 square plus root over 1 square. That means why I am discussing these things. That means to plot root over 2, you have to first take 1 unit. You have to first take 1 unit. This is the 1. So you have to first take 1 unit on the what? On the positive. Now see, this is your positive direction. Right hand side is your positive direction, and left hand side is your negative direction. That means you have to first take 1 unit. Okay. Suppose 1 minute. Suppose first you have to take 1 unit on the positive side. That means from 0. First you have to take 1 unit. Okay, 1 unit. Then again on this point, this is 1. So on this point, you have to draw a perpendicular of 1 unit. You have to draw a perpendicular of 1 unit. So with your scale, draw a, suppose 1 unit means with your scale, you can you can take 1 unit as any measurement. So for your convenience, you can take 1 centimeter equal to 1 unit. So here 1 unit is 1 centimeter, and here also you draw a perpendicular of 1 unit, 1 centimeter. Now this will be 1. Now see, when you draw a perpendicular, this will be 90 degree. Yes or no? Now if you suppose this is O, this point is suppose A, suppose this is point B. So now see, when you join OB, then OB will be the hypotenuse. Yes or no? Because this is a this is a right angle triangle. So this is the right angle at A. So OB will be hypotenuse. This is 1 unit. This is 1 unit. So according to Pythagoras theorem, it will be how much? It will be root over 1 square plus 1 square. Yes or no? It is nothing but what? Root over 2. That means the value of OB will be your root over 2. Yes. Now what we have to do? We have to take out the compass. Okay, we have to take out the compass and taking O as the center. Listen carefully. We have to take out the compass and taking O as the center and OB as the radius. We have to take O as the center and OB as the radius. We have to draw an arc. Suppose this is your O. I am drawing here, okay? O. Suppose this is your B point. This is your B point. Now you have joined OB. Now when you are taking O as the center and OB as the radius, you have to draw an arc of radius OB. Taking O as the center and OB as the radius, you have to draw an arc. Suppose this is the arc. So this arc will cut here, suppose here. So this point will be the, that means suppose this is a number line. Okay, this is a number line. This is the O. Taking O as the center, you have to draw an arc. You have to draw an arc of radius OB. This is the value of OB is root 2. We have already found 1, so it will be root 2. Now when you are draw an arc of radius OB, this arc will cut the number line, suppose point P. Yes or no? Now this point P denotes root 2 on the number line, because just now we have discussed that root 2 value, we don't know the exact value. Suppose this is 1.4345, yes or no? We don't know the exact value. Suppose 4, 5, 1.4356 like this. The root 2 value is 1.4356 like this up to infinity. So when we don't know the exact value, we cannot plot root 2 directly with the help of scale. Yes or no? Because we don't know the exact value root 2, but we know the approximate value. So we have to take the help of your compass. Yes or no? You have to take the help of your compass. So that's why when you draw a arc of radius OB with the help of your compass and draw a arc, this arc will cut at point P. Now this point P will denote the root 2 on the number line. Same here. This thing I am explaining separately, but you have to no need to draw this one. This is for understanding only. So you have to take O as the center, OB as the radius. You have to draw a what? You have to draw a arc. You have to draw an arc. So suppose this arc, it will be must be a dotted line. Okay. So this arc will cut suppose this point. So this point P will denote root 2. Okay. So this is the process. How can you plot your irrational number? Okay. So let me draw again. Suppose you are asked to plot root 2 on a number line. Suppose the first thing, that means you have to write down some statement here also. So I will give the statement. First, you have to draw one number line with the help of your scale and pencil. Draw a number line. Okay. Suppose 0 is your midpoint. Suppose this is your taking 1 centimeter gap. Write down 1, then 2, then 3, then suppose 4. Here also it will be -1, -2, -3, -4. Now what we'll have to do? First, you have to know root 2 you can write as root over 1 square plus 1 square. Yes or no? So to write down like this. Now taking from O, first you have to take a unit of 1 unit along the positive side. Then on this point, that means we have taken this one. Then on this point, you have to draw one perpendicular of 1 unit. So you can take any measurement. For our convenience, you can take 1 centimeter equal to 1 unit. So you draw one perpendicular of 1 unit. Okay, 1 unit. So draw one perpendicular of 1 unit. In page, it is not easy to draw. Okay, so 1 unit. Just suppose it is your point A. This is your point B. Now, when you join OB, okay. Now, what I am saying, that means this is 1, this is 1. So, according to Pythagoras Theorem, this will be root 2. Yes or no? Now, taking O as the center, with the help of your compass, taking O as the center and OB as the radius, you have to draw one arc. Suppose this is the arc, and this arc suppose cut here. So this point, suppose we have to denote this as point P. Okay. Suppose this is your point P. This is your point P. So this point P denotes your root over 2. You have to draw like this. Okay. Clear? Okay. Now write down the statement. All of you write down the statement. I am going to give you the statement. So all of you write down the statement. Write down first. You have to write down like this: root 2 equal to root over 1 square by 1 square. Then write down. All of you write down. 2 1 minute. 2 represent root over 2 on the number line, we take a length of what unit? 1 unit. Yes or no? 1 unit. We take a length of 1 unit from this is suppose 0 or this is suppose point O. Okay, 0 is denoted by point O. From O on the number line in what? In this is your positive direction and this is a negative direction. Yes or no? On the number line in positive direction, and we have taken 1 unit on the positive direction, that means in this direction, and 1 unit what? That means now we have to take this 1 unit here. Yes or no? 1 unit perpendicular and 1 unit perpendicular to it. Okay. Now say perpendicular, it is short form. This one and above this R. Okay. Perpendicular to it. Now see. Now O, that means we have taken 1 unit from O. We have taken 1 unit along the positive side. Then on this point we have taken 1 unit perpendicular to it. That means on this point we have taken 1 unit perpendicular. Now OA and OB will be OA and AB. OB will be a hypotenuse. Write down the hypotenuse of the, now see, this is a triangulation, no? Hypotenuse of the hypotenuse of the triangle thus form, hypotenuse of the triangle, this is the hypotenuse. Okay, it is not easy to write in the page, that's why the lines are not in the order. Yes or no? Thus, so perpendicular to it, full stop. The hypotenuse of the triangle thus form is of length, how much? Of length √2, because this is the length of √2. Yes or no? √2. Then with the help of compass, comma, with center O and radius OB, we have drawn an arc which cuts the number line, at point what? At point what? At point P. Yes or no? At point P, this arc cuts the number at point P. Yes or no? The point P corresponds to √2. Okay, so this statement you have to write down. That to represent √2 on the number line, comma, we take a length of 1 unit, that means this one, 1 unit from O on the number line in the positive direction and 1 unit perpendicular to it. Now the hypotenuse of the triangle does form each of length what? Each of length root 2, because according to Pythagoras theorem, this will be the hypotenuse and this is root 2. Now then with the help of compass, that means with the help of compass and taking O as the center and OB as the radius, we have taken an arc, and this arc cut the number line at point P. This point P denotes the root 2 on the number line. Clear? In the same way, suppose you are asked to see the example next. Suppose you are asked to plot, suppose root over, suppose say 5, root over 5. So root over 5, it is actually in your question, exercise 1.2, question number 3, root over 5. So root over 5 we can write as 2 square plus 1. Yes or no? 2 square plus 1. So that means, okay, now exercise 1.2, question number 3, all of you do as a homework, same process. That means now see, that means that's why I am saying that, or I am telling that you have to express the given number in this form. In the same way, root over 5 we can plot root over 2 square plus 1 square, because root over 2 square is 4, 4 plus 1 is 5. Now you have to first write down this one. Now see this one, draw one number line, suppose this is number line, and always remember number line, always give the your arrow mark, okay, on the two ends, both ends, okay. So this is your 0 is near the O. Suppose write down 1, then 2, suppose 3, with the same gap, with the in your copy write down the number line having the same gap and taking one gap as 1 centimeter with the help of scale, then 3, then suppose 5. Here it will be how much? -1, -2, -3, -4, -5. Now see, in the previous question we have taken 1 unit because here it is 1 and 1, but here first you have to take 1 unit then 1 unit, because 1 and 1 unit. Here we have to take first 2 unit then 1 unit, because this is the 2 unit, this is the 1 unit. So this is the point O. So first you have to take 2 unit. That means first if you take 2 unit, that means what? That means, okay, let me change the color of the pen. That means first you have to take what? First you have to take 2 unit. That means from here to here you have to take. See that in the previous one, this is 1 and 1. That's why we are taking 1 unit along the 1 unit from O along the positive direction, and 1 unit, and the perpendicular is also of length 1 unit. But here the base will be your, that means this is the base. You can write down 1 and 2 also, this is no problem. But for your convenience, you can write 2. So first you have to take 2 unit. Suppose this is point A, 2 unit. Then you have to draw. Here now see, here we have drawn a perpendicular of 1 unit, because here this is also 1, but here it is 1. So here also we have to draw a perpendicular 1 unit. Yes or no? Suppose this is 2, no, so 1 will be little bit smaller. Yes or no? Suppose this is, so this is 1 unit. This is 1 unit. Yes or no? This 2 unit. Suppose this is point B. Now see, this is 1, this is 2, this is denoted by 2 unit, and this is 1 unit. Now join OB. Join OB. Now OB will be how much? OB will be how much? OA square plus AB square. No need to write this one. For understand, I am writing this one. OB is this one, root over OA square plus OB square. Now OA, what is the value of OA? 2 square. What is the value of AB? 1 square. So it is your root over 4 plus 1. So it will be what? Root over 5. No need to write this one. Okay. For understand, I am writing this one. So OB will be then root over 5. Yes or no? OB will be root over 5. Now see, Again, you have to draw with the help of your compass, taking center as O. Taking center as O, you have to draw a arc of radius OB. Yes or no? That means with the help of the center O, you have to draw a arc of radius OB. Okay, suppose this is your B. So you have to draw an arc of radius OB. Now see. So when you draw an arc, it will be like this. And the value of root 5 is your, when you calculate the value of root 5 is your approximate 2.23606 like this. That means it will lie between 2 and 3. Yes or no? It will lie between 2 and 3. So when you draw an arc taking O as the center and OB as a radius, the arc will be like this. Between 2 and 3. Yes or no? So that means now, first let me change the color of your pen. Now that means this point is your P. Yes or no? This point is your P. This point will be your P because the arc cuts the number line here. Then this point P denote your root over 5. And the value root over 5 is this one, 2.23606 infinity. So now see, it will lie between 2 and 3. So it will be here. I think it will be, yes, it will be little bit here because I am not drawing this with compass now. That's why here it will be something, the measurement is something incorrect. Yes or no? But when you are drawing with your compass, with your accurate measurement, it will in between 2 and 3 and on the towards the 2. The arc will lie towards the 2 because 2 and 3, so it will be towards the 2. So it will be lie between 2 and 3. So this P denote your root over 5. Clear? The statement will be same as this one. Here you have to write down to represent root over 5. That means in the next question you have to write down. That means in the next question your statement will be same. Just in place of root over 2, you have to write root over 5. To represent root over 5 on the number line, same. We take a length of, here it will be how much? 2 units, because here it is 2 units. No, it is 2 units. So write down, you have to write down, we take a length of 2 units from O on the number line in positive direction and 1 unit perpendicular. Here also the perpendicular, that means this one is 1 unit. So you have to write down, to represent root over 5 on the number line, we take a length of 1 unit from O on the length of 2 units, 2 units from O on the number line and in positive direction and 1 unit perpendicularly. Same. Then after full stop, the hypotenuse of the triangle dash form is of length how much? Root over 5. Then with the help of compass, with center O and radius OB, we have drawn an arc which cuts the number line at point P. The point corresponds to root over 5. Same. Yes or no? So do your homework. Exercise 1.2, question number 3. All of you do your homework and today itself, and give me the snap of your homework in our WhatsApp group. I am going to check it. Okay. So this is clear. Now see the exercise 1.2, the others question. Question number 3 we have already done. Yes or no? Now see the other question. Question number 1, exercise 1.2. Question number 1. See the question number 1. Let me first read the question number. Yes, this is also true or false. State whether the following statement are true or false. Justify your answer. You have to justify. Now see, in the exam, if the first part is given, that means state whether the following statement are true or false. Justify your, that means if the first part is given, state whether the following statement are true or false. Second part is not given. Then you can write down just true or false. Okay, you will given the mark. But if the question itself it is given justify your answer, then you have to justify that why it is true or why it is false. Clear? So always remember this. Whenever the first part is given, state whether the following statements are true or false, and the question are given. Then according to your knowledge, you can write true or false, either true or false. No need to justify it. That means you know you don't need to show it. But when the second part is also given, to justify your answer, then you have to show it where it is true, where it is false. Clear? All of you clear about this? Okay. Now one thing. If you have any doubt, be frank. Tell me if you have any doubt or if you have any problem regarding the explanation part, or if you don't understand anything, just tell me in our WhatsApp group, and I am trying to improve my explanation in my next video or next class. Okay, so be frank. Okay, now see the question number 1. First question: state whether the following numbers are true or false. State whether the following numbers are true or false. Justify your answer. The first one is every irrational number is a real number. Now see the first question: every irrational number is a real number. Let me write down the first question. Every irrational number is a real number. Now all of you tell me whether it is true or false. Every irrational number is a real number. Every irrational number is a real number. Yes, it is true. That's now we have discussed. Yes or no? That means what is the definition of real number? Real number are the combination of irrational number, rational number, natural. Yes or no? Irrational number, rational number, the natural number, whole number. All the combination of all the numbers are the real number. Yes or no? The number which we can plot in a number line are called real number, and we know that irrational number we can plot in the number line. That's not we have plotted now. That means root over 5, root over 2 with the help of compass. With the help of the compass, we have already plotted root over 2 is a irrational number. Yes or no? Root over 5 is irrational number, and we have already plotted root over 2, root over 5 in our number line. So here it says every irrational number is a real number. Yes, it is true because every irrational number is a real number. Yes or no? So your answer will be what? Your answer will be true. So write down true. So write down first. The answer will be true because all rational number and irrational numbers, because all rational numbers and irrational numbers, what? Because all rational numbers and irrational numbers are what? Numbers together make up the what? Collection of real number, that is R. Yes or no? Yes or no? Because real number, what is the definition of real number? The combination or the collection of irrational number, rational number, then your natural number, your whole number. This is a real number. That is true. Every irrational number is a real number. Yes or no? It is true that every irrational number is a real number. So now see the next one. This is number 1. The next one, number 2. What is the number 2? Number 2 is every point on the number line is of the form root over m, where m is a natural number. All of you write down, see the number 2. The question is every point on the number line is of the form root over m, where m is a where m is a natural number, where m is a natural number. Now see, is it true every point on the number line? Try to understand the statement. First, you have to try to understand and think carefully. Every point on the number line, every point on the number line, every point on the number line is of the form, every point on the number line is of the form what? Every point on a number line is of the form root over m, where m is a natural number. Is it true or false? It is false. Why? Now see, it is false. Why? The answer will be false. Now see, it says every point on the number line is of the form root over m. Suppose, now see, it says every point. This is 0, this is your 1, this is your 2, this is your 3. No need to draw this one, okay? This is for understanding. Root over 4, then root over minus 1, root over minus 2, root over minus 3, root over minus 4. No. Every point on the number line is of the form root over m, where m is a natural number. Where m is a natural number. Yes or no? Now see, root over 1, every point on the number line is of the form root over m. Now see, root over 4, see carefully, okay? Try to understand the statement. Every point on the number line is of the form root over m. Now, this is the 4, suppose. Every point, this is the point 4. 4, if you write down root over 4, this is 2. Yes, every point on the number line is of the form root over m. That means root over 4 is nothing but 2. Yes or no? That means root over 4, we can write down root over what? That means 2, we can write root over 4. Yes or no? That means 2, we can write root over 4. That means root over 4 is a number. Every point, that means root over 4 is on a number line where it can be plotted on a number line. 2, we can plot on the number line. That's why root over 4 is 2. In the same way, root over 2 also we can plot. Just now we have plotted root over 2 here. Yes or no? Just now we have plotted root over 2 here with the help of compass. Just now root over 5 also we can plot. Root over 5 also we can plot. That means the main thing is I am going to discuss that thing is every point on number line is of the form what? Root over m. It is not, is of the form root over m. Every point, we can't plot every point in the form root over m. Why? Because root over 2 we can plot, root over 3 you can plot, root over 4 also you can plot. Root over 4 is nothing but 2. Root over 3 also you can plot. Root over 5 also you can plot. Yes or no? Something it will be in a fraction or it will be in decimal number, but decimal number we can plot it with the help of compass. But root over 1 we cannot plot. Why? Because on the number line we can only plot the real numbers. Yes or no? But root over -1 we can't plot. Why? Because in the beginning of this class I have discussed the imaginary number. Yes or no? This is imaginary numbers. Yes or no? We have just discussed this one. Imaginary numbers. Root over 1, root over -1, root over -4, 2y. Yes or no? These are imaginary numbers, and we can't plot imaginary numbers on a number line. We can only plot the real number on a number line. In the beginning of our class, I have discussed this thing: imaginary number, real number. We can only plot the real numbers on the number line. But here the statement says that every point on the number line is of the form root over m. Now see, every point root over 4 is nothing but 2, so 2 we can plot. Yes, then suppose root over 2 is your approximate 1.73, suppose. So 1.73, that means it is nothing but root over 2. So root over 2 we can plot. Then suppose root over 2 is your 1.44. Root over 3 is your 1.73. So 1.73 we can plot. Now see, 1.73 is a number. Every point of number. So 1.73 is a number in the form of root over 3. Root over 3 you can plot. 1.44 is a number in the form of root over 2. That's a root over 2 we can also plot, but we can't plot root over -1. Then we can't plot root over -2. Yes or no? Because these are the imaginary numbers. That's why we can't plot every point. We can only plot the positive numbers. We can only plot the number. Suppose the statement is given like this: every positive number is of the form of root over m, where m is a natural number, then it will be correct. But here says every point. Every point means what? It will include negative number also, positive number also. Negative number, root over or negative number we can't plot. That's why this will be false. So your answer will be like this. Write down false. Write down false. False. Write down no negative number can be. No negative number can be square root of any natural number. Yes or no? Now see, no negative number can be square root of any natural number. Now see, here on the number line, negative number is also present, positive number is also present. Yes or no? But 2 we can plot because 2 is a square root of 4. Yes or no? Suppose here we can plot 9 also, or we can plot 3 also. 3 we can also plot because 3 is a square root of 9. That means every positive number we can plot. Every positive number in the form of root over m we can plot. But see this one. No negative number can be square root of any natural number. Natural number means what? From 0 to, sorry, natural number is from 1 to infinity. 1, 2, 3, 4, 5, 6, 7, up to infinity, 16 up to infinity. These are the natural number. Yes or no? Now, no negative number can be square root of any natural number because in the number line, positive number is also there. Negative number is also there. Yes or no? In the number line, negative number is also there. So, but here, no negative number can be square root of any natural number. Now see, -1 is not a square root of any natural number. -2 is not a square root of any natural number. 2 is a square root of 4. 4 is also a natural number, and 2 is a square root of 4. But -2 is not a square root of any natural number because because root over -2 will be imaginary number, or root over -4 is an imaginary number. It will be 2i, imaginary number. But root over 4 is a natural number. 4 is a natural number, and root over, now see, square root of 4, 2 we can plot in the number line. Yes or no? Square root of 16, 4 we can plot in the number line. Square root of 9, 3 we can plot in the number line. But try to understand this one. But square root of -16, it will be 4i. Square root of -9, it is 3i. So this number we can't plot in the number line because these are the imaginary numbers. So the reason will be no negative number can be square root of any natural number. Have you understood the statement? No negative number can be square root of any natural number. That means, now see, no negative number can be square root of any natural. Try to understand this one. No negative number can be square root of any natural number. Now see, suppose -2. -2 is nothing but what? Suppose -4. Root over -4. So it is 2i. Yes or no? So negative number cannot be a square root of any natural number. 4. The root over 4 will be your 2, not -2. Root over 9 will be your 3, not -3. So that's why no negative number can be square root of any natural number. Natural number is from 1 to positive number from 1 to infinity. These are the natural number. So that's why here every point on the number line is of the form of root over m. This will be a wrong. Clear? Okay. If you have any doubt regarding this, that ask me in our WhatsApp group. I will explain again. Now see the next point. See the next point. What is the next point? The next statement states that every real number is an irrational number. The next statement says that exercise your 1.2 Question number 1. Question number 1-3. Every real number is an irrational number. Now use your common sense, tell me. Every real number is an irrational number. Is it true? Is it true? False. Because rational number are also real number. Yes or no? Here it says that every real number is an irrational number. Is it false? The vice versa will be true. That means every irrational number is a real number, because we have already discussed that what is the definition of real number. Real number is the collection of rational number, irrational number, natural number, yes or no, whole number. So every irrational number is a real number, but every real number is an irrational number. Is it false? So why it is false? Because real number is also a rational number can be also a real number. Yes or no? Suppose 5/4 is also a real number. 5/4 is also a real number, and root over 2 is also a real number. 5/4 is also a real number, and root over 2 is also a real number. But 5/4 is a rational number. But 5/4 is a rational number, and root over 2 is a irrational number. Irrational number. But here says that every real number is an irrational number. But now see, here real number is a rational also, irrational also. So it will be wrong. Every real number is a rational. It will be wrong. But the vice versa will be correct. Every real number is an irrational number. Put every real number is an irrational number. It will be correct. Or every real number is every real number. It will be also false. Suppose every real number is a rational number, it will be false, because some real number can be irrational number also. So suppose one statement is given, some real number can be a rational number, then it will be true. Some real number can be a rational number, or some real number can be irrational number. In the same way, suppose it says that some real number is an irrational number, then it will be true. Okay, then it will be true. Suppose it says that some real number is an irrational number, then it will be true. But here says every real number is an irrational number. It will be false, because here just now we have proved that real number can be rational also, real number can be irrational also. So it will be false, yes or no? So the answer will be false. False. Write down false because real number can be rational number also. Yes or no? Real number can be what? Real number can be or you can write like this: false because all rational numbers are real numbers also. Yes or no? Rational number is also real number. Irrational number, all rational numbers are real numbers. Yes or no? All irrational numbers are also a real number. It will be true. But every real number is an irrational number. It will be false. A real number can be rational also, irrational also. Understand? Yes or no? Every real number is an irrational number. It will be false. But every rational number is a real number. It is true, because 5/4 is true. All the rational numbers are real number. In the same way, all irrational number is a real number. It's also true. But every real number is an irrational number. It will be false. In the same way, suppose every rational number is a real number is true. Yes or no? But all the irrational number is also real number. It will be also true. All the irrational number is also real number. The vice versa will be true, but it will be not true. Every real number is an irrational number. The answer will be false, because all rational number are real number also. Okay. But here it says that every real number is an irrational number. But just now we have proved that real number can be rational number also. That's why false. All rational numbers are real numbers also. Okay. Now see the next question. Question number 2. What is the question number 2 says that? Question number 2 says that your are the square root of all positive integers irrational? Are the square root of all positive integers irrational? That's now I have discussed. Yes or no? Here it says that you are asked that all are the square root of all positive number is irrational. See, square root of 2 is irrational because it is, we don't know the approximate value 1.4445 or 4356 up to this. Root over 3 is also irrational 1.7289 up to this infinity up to infinity. So this is a non-time meeting. That's why this is irrational. But here it says that every or all positive number is irrational number is false. Why? Because root over 4 is also a positive number and root over 4 is 2. But it is a real number, yes or no? But it is a real number. So it will be what? You are asked that are the square root of all positive integer irrational? Your answer will be no, because 16 is your positive number and square root of 16 is 4, which is a rational number. So your answer will be no. Square root of positive integers, the answer will be square root of all positive integers are not irrational. Why? Because just now I have proved yes or no. Because root over 4 is also a positive number, but square root of 4 is 2, which is a rational number, and root over 16 is also a positive number, but square root of 16 is also a rational number. Yes or no? So your answer will be, write down the answer. Your answer will be, sorry, you are asked to give an example also. If not, give an example of the square root of number that is a rational number. So root over 4 is an example. So write down square root of all positive integers are not irrational. Why? Because just now I have proved square root of 4 is rational. Yes or no? So if not, give an example. So write down this one. For example, root over 4 equal to 2, or root over 9 equal to 3, or you can give root over 16 equal to 4. You can give any example, anyone, okay? You are given only one example, so you can write only one. So for example, root over 4 equal to 2, which is an what? Your rational number. Yes or no? So write down the answer will be this one. Square root of, it will be question number 2. Square root of, no need to write this one. This is for your understanding only. This part is your understanding only. Square root of all positive integers are not irrational. For example, root over 4 equal to 2, which is an irrational number. Clear? Now question number 3. Just now we have discussed question number 3. So how root over 5 can be represented on the number line? I have given the homework. Yes or no? I have given the homework. This one, the question number 3, exercise 1.2, question number 3. So your homework is exercise 1.2, question number 3. All of you do the homework and give me the snap of your homework today itself in our WhatsApp group. I am going to say, okay? So thank you. Next, that means tomorrow we are going to discuss about real numbers. Next topic, that means real numbers and the decimal expansion. Okay? So thank you.